it is time for the series to return, except with some major modifications. So this is episode 1 of making a fighting game. I will be very slowly attempting to make a fighting game, and I already have one video up on the channel that is technically also part of the series. I titled it Part 0A. I also had scripted and recorded Part 0B, and I also had scripted Part 0C, and none of them had anything to do with fighting games. It was just me sitting down here for a few hours trying to explain basic coding principles related to C#. And I stopped making and uploading them because that wasn't what I was trying to get across through the videos. So for this new reboot, I am not using C#. I'm not even using the Unity engine. Instead, I will be using the Game Maker engine, which is also free to use. I will be using the free version. And Game Maker is 1,000 times simpler and quicker to get into than any other engine I've tried. However, it is both limited and not efficient. So if you ever wanted to get serious about actually making a fighting game as a programmer, then I would highly recommend the Unity engine or the Unreal engine. But for the purposes of this series of videos, which is not really focused on the implementation part of things, Game Maker is perfect because we'll be making a 2D fighting game. And I don't really care about the efficiency because we won't be making fancy graphics and things that'll slow down the PC. So this series will be focused on the why I'm doing things, less of the how I'm doing things. Now, as far as Game Maker's concerned, the free version has all of the things that you need in order to make a basic 2D game. However, if you want to export it to various platforms that your friends can play on, you'll need to at least subscribe for 1 month for $5, or you can subscribe for a year for $50 for the lowest tier of subscription. And until you spend money, you can only make games for the Opera browser, I guess, or something like that. But that doesn't matter while you're still in the development phase of the game. That only matters when you start trying to get people to play it. Now, I have made a fighting game in Unity before, and I've made a video about that game. It
sucks.
But it was the very first... No, it was the second video game I ever made, ever. And it was the first video game that I spent more than like a week making. And you can find that video in the description below. But anyway, now we can go into Game Maker. And when you boot up Game Maker, you'll get some sort of window like this. As you can see, I already have a project named Make a Fighting Game _test. We will be making a new project, a new blank project called Making a Fighting Game. And this is what we get. This is, voila, a blank window. I tried for a very short amount of time to do this series in Unreal Engine, and it did not give me a truly blank workspace when I told it to make a truly blank workspace, and I really got annoyed by the things that Unity did for me that I didn't want. Game Maker does not do that. Game Maker literally just creates a room. That's what it creates. So over here on the right we have rooms. All it does is create a room. And everything else is completely blank. There is nothing else in our scene. We have no control over anything. We are starting literally from scratch. Now, the very first thing you want to do is go up to this little icon up here in the top right and click it and take it to test. Because if you don't do this, every time you run the game, it'll open up your browser and start playing your game through the browser. And this is because, again, the only main platform that you're allowed to export to with the free version is the Opera GX stuff, which is a browser. So by opening it in test, now whenever I click play, it literally opens up a window, and obviously there's nothing in the window because we haven't done anything yet. And really there's only a handful of things that you need to understand when getting started with Game Maker. So first we have workspaces. Workspaces are just a collection of windows that I'll open that I can edit things in. Workspaces do not actually exist within the game. It's just an interface for us to add events or scripts or change certain values about various things that will be in the game. Rooms are actually the game. So if I double click on room, you can see it opens up the room. And you can zoom and move it around. So obviously there's nothing in our room. If we don't put anything into our room, then there will be nothing in the game. So we will need something in our room eventually. We can go to our background here and change our background color if we wanted to. We can change it to like a gray. Let's go with this color. Let's go with darker. There we go. Gray. Now if we press play, we have a gray background instead of a black background. So the instance layer, so instances are basically things that exist within the game. We need to create instances of objects. So let me right click objects and create an object. Boom, and we have our object. And most game developers will tell you the very first thing you do when making a new game is make some sort of object. I call mine _GM. And we'll be placing this object in our room, so just take object _GM and place it anywhere. I'm OCD, so I'm going to try to put it at position 00 because, well, why not? And I can see it's up in the top left corner. When we created our object, it showed up in the workspace panel. And events. So events are things that allow objects to do things. And we can see various events including create, destroy, cleanup, step, alarm, draw, whatever. The main things that I want to focus on today are create and step. So let's start with the create. And again, there's nothing. This is glorious. So what do we want to do for our first episode? Well, my end goal is to have some sort of visual representation of the user's inputs on the screen. And so I will show various examples from many different fighting games of different ways of doing this. Basically, any fighting game with a good training mode will also have some sort of input display or input history. So the first thing that I want to do is I want to make sure that only one GM object is created ever. So let's say if, and again, I'm not going to be going too deep into like how to program. It'll be pretty obvious what I'm doing, hopefully, because this language is not like a typical programming language. GameMaker uses its own language called GameMaker language, I think. It's just called GML. And it's very, very, very easy to use. It's an interpretive language, which means that you don't have to actually like declare your variables. Let's say instance number. This is a built-in function, and we can give it _GM. And you can see when we type it, it turned red. That means it recognizes that as an object. And if the instance number is greater than 1, then we can do the things that we want to do. If it's not, then we probably shouldn't do anything, and instead we'll say instance destroy. So what this will do is it will do various stuff. We'll put all our code in here. If, and only if, there is only one instance of GM. One of the very first things that you should know how to do is create comments. And in order to create comments, you just do //. And so I can say anything I want here, it will not do anything. However, when we come back to this code later, we'll be able to know exactly what this does. So this is the game master object. And it is created once when the game boots, is never destroyed, and never created again. And we can make sure it is never destroyed by saying persistent equals true. Another thing that I want to do is set the frame rate. So every fighting game basically runs at 60 FPS. So the way to do this is simply game set speed, and then we can say 60, and then we set the game speed FPS. And so one of the next things that you really need to know how to do is read from the console. So the way you do that is just with show debug message. Yeah. and it can be basically anything. I mean, hello world. Let's do it like that. Oh, wait. Hold on, I did this wrong. This is saying if the instance is greater than 1, so if there's at least 2, that's not correct. It needs to, well, I can make it correct by saying this. By putting it up here like this. My bad. So now it's saying if there's greater than 1, so if there's at least 2, we're going to destroy ourselves. If there is not greater than 1, then there is only 1, and we can do our things here. There we go. Now if we hit play, we can go down here, close it out, but in the debug, it printed out hello world. There you go. So now that's our way of confirming that this line of code is being run, which means that all of these are being run. Cool. So what do we want to do? Well, before we actually get to the input display, there's a little bit of setup that we need to do. And I want to be able to write settings to a file, and basically everything we do is going to be an object. So let's create an object, and I'll call it O_settings. So all of our objects from here on out will be O_ something. So this will be O_settings, contains all changeable user settings. And more specifically, there will be an external file. So this is not an external file, but what I want to happen is for the user to be able to change their settings in the game, close the game, open the game at a later point, and have the settings saved. You can't do that through objects. You need to do that through some sort of external file. And the easiest way to do that is with any open and any close. But we're not going to do that here. We'll do that in a different file. So settings needs to be persistent true as well. And up in our GM here, we will need to create it. So the way you create instances of objects, well, you could, theoretically, you could go back to your room and drag O_settings in like that, but I don't want to do that. The way I'll do it is I'll instance create. There are two different instance create methods. There's a depth method and a layer method. I use the depth method most of the time, and the way this works is you give it an X position, a Y position, and a depth, and then I'll put the object forth. So this is the syntax for creating something with depth. You can also do things with layers. I won't talk about layers in this video. Depth is much easier to understand. So when things have some sort of visual representation, depth will determine which is drawn first. So the least deep things, or the things with the lowest depth, are drawn on top. So if I wanted to make sure something was drawn on top of everything else, I would put, like, you know, a big number here. But O_settings won't have a sprite attached to it, so it doesn't really matter. Also, the X and Y won't matter at all. So this is going to be our settings. I want to be able to access the settings from anywhere. So what I'm going to do is I'm going to create a global variable. So what I can do is I can say global dot settings. I'll make it all caps. Global dot settings equals instance. So now the object will be created, and now we can just type global dot settings, and it'll automatically go and find that wherever it is. I want to make it full screen. So let's say window set full screen, and then true, not true, true. And now when we boot up the game, it'll be full screen. Boom, easy. Cool, so now we can go into our settings. So how many settings do we need? Well, we need a setting for each input the player has. So now we're sort of diving into the input display side of things. All right, MS Paint, let's go. Here we go. So let's do one input for each button. So A, B, C, and D. And then, so you might think, well, okay, a fighting game uses 9 directions, right? So you have numpad notation, for example. You have 1, 2, 3, 4, 5, 6, 7, 8, 9. Most fighting games are actually not programmed this way. This is a pretty bad way to program it, because like, what if the player is playing on a keyboard? Do you want to have a button for each of the 9 directions? No, you only have 4 buttons, and if none of the buttons are being pressed, you go 5. If the left button is being pressed, you go 4. If the down button is being pressed, you go 2. Forward is 6. Up is 8. But you get the diagonals by pressing a combination of 2 buttons. So up and left will give you the up-left diagonal, or 7. So you don't actually need 9 different variables. You need only 4 of them. You have, you know, up, down, left, right. So you have 4 here and 4 here. You will also need some sort of other variable that determines if they're on a keyboard or if they're on a gamepad. And if they are on a gamepad, which gamepad are they on? So that's a total of 9 variables. So we need 9 variables. Also, there's a cool little thing in a lot of text editors where you can use Shift-Alt. And now I can type to several different rows at the same time, which is very useful. So we'll need different ones for player 1 and player 2. Player 1 input up. I'll do it like that. And then for now, I'll set them all to 0, but we'll make that more specific later on. So all of these will be player 2. And then here we have up, down, left, right. And then for our buttons, we'll just do A, B, C, D. And then gamepad num. I'll do it like that. And now all these can be 2. So there we go. So now we have 9 variables for each player. Get in the habit of using comments. Let's do player input. To set up all these variables, I'm going to create a script. And I name all my scripts, so you can do S underscore, but I usually do that for sprites. So for scripts, I do Z underscore. Let's do update settings object. So how do scripts work? Basically, what I want to do is I want to be able to call a script whenever I want to update the object. Updates the settings object values according to the external ini file. We can add arguments or parameters into this. I'll call it S for settings, and I'll set it to equal -1. So now what this means is I could go in here and I can say Z update. I'll just tab it over. And now we could leave it empty. And if we leave this empty, this function will treat S as -1. Or we could give it something. And specifically, I want to give it self, because if I don't give it self, it breaks. But what I'm going to do is that if S equals -1, that means they didn't pass in an S value. So we can say S equals global.settings. The reason I need to have it like this is because if I left this empty, it would crash. It crashes here because global variable name settings not set before reading it. So this has to do with when we set it up here. We technically wrote it in here, but the create event is run immediately. So as soon as the game reads this, it is running this, which means that it's running this, which means that it's running this line of code here, and which means that it's trying to read global.settings here while it's writing it. So it is not finished writing global.settings to a value. However, it is trying to read it over here. The way I do this is specifically when we're in the create function. I type self here. And now that will work because we're not passing it via this global.settings reference anymore. We're just giving it the object directly because we're in the object already. However, any other time that we need to run this function, we can just get rid of the self and it'll work. So now let's update our setting. The way we do this is we do any underscore open and any underscore close. Make sure you close the any file, otherwise it'll just remain open for the entire game, which is not a good idea. Especially if you're updating your settings like multiple times, you'll open up like 30 different files and the game will crash probably. So don't do that. Make sure you close your any file every time you open it. So we can call this whatever we want. I'll call it, let's see, working directory. This makes sure you're putting the file in the correct place, like where the game is, and then we can call it whatever we want. So let's say settings.a. And so the way any files are set up is, so this is the game folder for my test game, and it has settings.ini in it. And here you can see there's a header. There's a header up here, as well as, oh, ignore those. There's a header up here, as well as all the variables that we put into our settings. So we can do any read. So there's two different versions. You have the real and the string. Basically, you use string when you're writing strings, and you use real when you're writing numbers. Basically, all of these will be strings, except for the gamepad num. So let's go string, and we need the header, the variable name, and we will give it a default value. We'll put it in a variable. So let's do s.p1 underscore input up equals. So this will set the variable that we put up here. And so what it does, well, first of all, if there is no file called settings.ini, it'll create it. And down here, if there is a variable in this heading, which I'll call player input, of the variable p1 input up, or I guess it's just up, since we already have input over here. And this will be the default value. If this variable already exists in the file, it'll ignore this. But if this variable does not already exist in the file, it'll create one of this value. And so the way GameMaker handles keyboard input, so I'll do keyboard for now, is you have to put it around here. And ord is a function that translates a string, like a W. Technically, it makes it a number. It's probably like 30 or something for W. I don't know. Later on, we will be able to say keyboard check. And then you'll put in whatever value a key on your keyboard has. And I don't know off the top of my head what number is assigned to the W key, but I can just do ord W, and now that will automatically translate that to whatever the number is. I don't need to know what the number is, I don't care. And so now that we have this set up to a variable in our settings, now we can, instead of hard coding or W, we can just type S whatever P1 input up is. There we go. And that will work the exact same way, because this line will set the value of this to be or W if it's not already in the file. If it's already in the file as something else, it will be that something else. But we're not there yet. All right, now we have to do this line again for each of the variables. So up, down, left, right, A, B, C, D, and gamepad num. And the gamepad num will be a real, not a string. And just for the sake of being good looking, I will make all these equal. This also lets me do this again. So all these will be under player inputs. And let's see, P1 underscore down, left, right, A, B. Now for the gamepad num, if it's negative, that equals keyboard. If it's non-negative gamepad slots. So the way it handles gamepad slots is it starts at 0 and counts up. So the first gamepad slot will be gamepad num 0, and anything less than 0 will consider it a keyboard. So here, and then we'll have it -1. So player input P1 gamepad num. There we go. -1, and then we can copy this for player 2. All these P2, all these P2. And I have an arcade stick plugged in right now. I can just change it if I wanted to. Yeah, I'll actually do that. So player 2 will be keyboard, player 1 will be gamepad. And so again, the way you handle gamepads is gamepad button check. So just like keyboard check, you have gamepad button check. It's exactly the same, but notice you have to include the device. So you have to actually include the gamepad num. So you would do s dot P1 input gamepad num, comma P1 input whatever. It would look something like this. So just like keyboard, where it takes a key and assigns it a number, it does the exact same thing for gamepads. And the way you access those is with GP underscore, and then you can see here I can scroll through a ton of different buttons. You have start, that's L3, that's R3. You have shoulder buttons. You have pad down, pad left, pad right, pad up. For up, pad view. Down is GP underscore pad D. Left GP pad R. And then I'm gonna be honest, I don't remember which button's which for these. GP pad GP space. It probably goes 1, 2, 3, 4. So I would go 1. So I would go 1, 3, 2, 4. Two. That'll be my guess. That might be incorrect. For player 2, will put in the ords. So ord. Down would be S. Ord. Left would be A. Right would be D. A could be a lot of things. If you don't want to use ord, you can also do VK underscore, and it'll give you several other keys, like the divide key, the F keys, the alt keys, the shift keys, the numpad keys. I'll probably do numpad over here. So I'll do numpad 4 for A, okay, numpad 1, C 5. Whenever a player boots up the game for the first time, all of these values will be set as the defaults. If the player is booting up the game not for the first time and there's already a settings.ini file in their system, it will ignore these and it will put into the variable whatever value is in the file. And make sure you have your ini underscore closed here. This is very important. We're done with this script, which means that we're actually done with this for now. Now to get an actual joystick in the game, I'm going to create an object called O underscore virtual joystick. You may have heard this term before. There are some things that can go very wrong at this stage of development. Particularly with keyboards and hitbox controllers, you are allowed to press left and right at the same time. Now, if you played Marvel vs. Capcom 3 when it first came out, vanilla Marvel 3, players could press left and right at the same time. And in order to block attacks in that game, you had to press left or right, whichever one was opposite of the opponent. If the opponent was over here, you had to hold this direction. If the opponent was over here, you had to hold this direction. What you could do is you could hold both directions at once and block everything. So we don't want that. To avoid that, we will be using a virtual joystick, which takes all the input. You have left, right, down and up. We want to take all of those and convert it into one joystick. one joystick that is either in the down position, or it's in the up position, or it's in the left, or the up left, or, it's in one of these 9 positions. We want to take that and turn it into this numpad notation that I was talking about earlier, where it exists in one of 9 positions. And that is what a virtual joystick will do. It'll also contain the buttons, but the buttons will just be like 1-to-1. The buttons will just be like 1-to-1. So A and then A. There is more to talk about here. If the user's controller somehow presses left and right at the same time, what do we do? There's really 2 ways to go about this. The first is to say, well, if you press left, press right equals neither. You can say neither. You can also say it equals whichever one came first. So that would be if they hit left and then right, it just keeps left. And if they hit right and then left, it just keeps the right. I don't know which of those is better for the game, honestly. There's a lot of people that claim that this is better, but I think this is better. It's also the easier one to implement, so I will be doing that one. Most hitbox controllers are programmed to set left and right together equals neither left nor right, but up and down equals up. That is the standard for most hitbox controllers. If the controller is programmed to do that, there is nothing that we can do as the game developers to tell the difference between up and up plus down, because the controller will just tell us it's just holding up. I will not hard program that into the game. I will do up plus down equals neither up nor down. I think that is the easiest to implement, and is also just probably better, because having it the other way is horrible. Let's go into our virtual joystick. We'll create mappings. So we have a mapping for each of our directions. This will not be seen by the user at all, so I'm okay with using lowercase and uppercase for the various things. So U, D, L, R, A, B, C. So these will be the keys that the user has bound to that particular input. On top of those, we will need individual variables that will change. So let me clarify this. The input mappings the user has set in settings. These next variables will be booleans, or true, false values, that change every frame based on current user input. So this is where we'll have that difference between the 4 keys versus 1 virtual joystick. And I will do that with dir. Dir, and we'll just have it at 5. We'll have U, D, L, R. And then we'll have A, B, C, and D. Oops. B, C, D. So all of these variables will be set based on the mappings and what is currently happening with the controller being used. Let's see, we'll also need gamepad. Num. So that all happens when we create a virtual joystick. We need things to happen every frame, and so every frame, the step function happens. More specifically, the begin step function for all objects happens, and then the step function for all objects happens, and then the end step function for all objects happens. I'll put everything in the step function. First of all, we have keyboard versus gamepad. Update variables according to current player input. Alright, so keyboard is if gamepad num is less than 0, and gamepad is the else. In the keyboard section, we will have to update all of these variables to the keyboard check, and these will be mapping whatever. U, D, L, R, A, B, C, D, D, C, D, A, R, L, D. There we go. So every frame, this function will run, and it'll update all of these variables, so all of these variables down here, according to whether or not that key is being pressed on the key. Under the gamepad, we need to update the same variables, but with gamepad button check. Again, remember we need the gamepad num here And then we have mapping underscore u. There we go. Now we have to deal with this dir variable. So we need dir equals a digit between 1 and 9. So this is what your numpad looks like. You can think of this as a joystick. So if the joystick is in like a neutral position where you're not touching it, we say that's 5. And if the joystick goes up, it's 8. If it goes down, it's 2. If it goes left, it's 4. If it goes right, it's 6, etc. That is standard FGC numpad notation. I should specify according to standard right-facing FGC numpad notation, because usually we flip it if the character switches sides. And so, okay, right now we have 4 variables, the U, D, L, and R variables, and we need to translate those variables into this numpad notation. So how do we do that in the code? Well, it's actually very easy. Start with dir equals 5. If u, we'll add 3. So saying a dir plus equals 3 is the same as saying dir equals dir plus 3. That's exactly the same line of code, it's just shorter. If d dir minus equals 3, if dir minus equals 1, if r dir plus equals 1. And we're done. We're entirely done with our virtual joystick. And a good thing to do when you actually do something is to test it. So let's go show debug message. Of course, we have to create our virtual joystick. Instead of creating a virtual joystick this way, let's write a script called z underscore create virtual joystick. We can just type in one variable. We can say type, if they pass in 1, we can say it's player 1. It will just automatically load all of player 1's inputs right here. And 2 equals player 2. And we can do this with a switch statement if we wanted to. And to make this more concise, we'll create a variable called s global. And so the way switch statements work is we give it a variable, and then we say like case 1. And now if that variable is a 1, we do all of this stuff. And if the variable is a 2, we do all of this stuff. And if it's none of those, we can say default. And if none of these cases are true, it just does the default. We need to create a virtual joystick here. Let's call it VJ equals instance create depth 0, 0, 0. Oh, virtual joystick. So now we can say VJ dot gamepad equals s dot p1 underscore input underscore gamepad underscore dot VJ dot mapping u d l and that's it. Now we do the same for player 2, and we're done. So now if we go into here, we can say z create virtual joystick player 1. And so now let me actually get rid of full screen so that we can see the console as it's happening. That's good. I'm not touching anything. It says 5. Oh, I need my gamepad. If I move the joystick, perfect. You can see the digits down there are changing. If I hold left, it's 4. If I hold right, it goes to 6. If I hold up, it goes to 8. If I hold down, it goes to 2. Let's try 1. Let's try 3. Let's try 7. Let's try 9. It works perfectly nice. Now, for the final thing, we need to take those digits, and instead of printing them to the console, we want to print them on the screen. So I can bring back full screen, and instead of doing this, I want to instead go and create an input display object. So let's go ahead and create an input display. Actually, before we do that, I'm going to create an OMT. And this object will have nothing. I'm going to close this. We're not going to do anything with that. I'm going to create another script called z underscore create empty. And so it's a good idea to have this if you're going to create things through scripts that only need to have a visual on them and nothing else. I could take this time to talk about how GameMaker handles visuals. Let's just type e equals instance create depth. I'll actually let you pass in variables here. So I'll give it sprite, x position, y position, depth. I need to put an underscore there because depth by itself is a thing in GameMaker. You can't do that. The way this works is x first, y position, depth, O empty here, and then we can say e dot sprite index equals sprite. So, for example, I've already made sprites, and so here's what I have, is I've basically created different images. The background will always be shown, and then the stick will be in one of these positions depending on where dir is, and then the buttons can also light up if the buttons are being pressed. And I've put them all at the same resolution, so I can just put all of the images at the same point and they'll be correct. We'll need to create different sprites for each of them. So let's go to sprites, right click, create sprite. Let's say s underscore input display background, create another sprite, s underscore input display stick, create sprite, s underscore input display a, and then there'll be one of these for each of the buttons. There you go. So now all you have to do is go to import and import the image that you want. Actually, I need to go to edit image and I need to add a blank frame because sometimes this will not be shown and sometimes it will be shown. There is a way to just hide sprites, but I'd rather not do that. Image, import C, then add a blank frame at the beginning. C, import, add a blank frame at the beginning. D, import, D, add a blank frame, blank frame. Ooh, we gotta do the background now. I'll do the same with the background, right? Oh, let's import, and I'll do the same where I edit and add a frame, because why not? And then the stick needs, oops. We're gonna change this, the index of this sprite based on the dir variable. So we're gonna put all of them in there, put a blank frame at the beginning. Is it in order? 1, 2, 3, 4, 5, 6. Yeah, I'm gonna say image speed equals 0. So normally when you create a sprite, you have a speed on it. Here, you can see there's a default FPS. So this thing by default would swap between frames 30 times per second, which is not what we want. So whenever we create one of these, we want to make sure the image speed is set to 0. So image speed 1 would set it to whatever it's written as in the sprite details. So this would be 30 FPS. This would be 0. And then we also want to return E. Actually, I'm going to show this off in this. I'm going to return VJ at the very end here. Return VJ. So now what we can do over in here when we create our virtual joystick is we can say P1's VJ. Now we have the virtual joystick that we created in this function as a variable in our script here. Let's create our input display. A new object, O underscore input display. So here we'll have dir, obviously. We'll need A equals false, B equals false, C equals false, C equals false. And then we'll set all these the same way that we made our virtual joystick. We'll create a script called z underscore create input display, and we'll pass it in a joystick to read from, and that's it, I guess. Well, we'll tell it where to go, right? Position, y position, and then we'll create instance, create position, y position, We want this to be like in front of things. So let's give it a negative depth, like -5. And then we'll create, input display. And then we'll say that is the display, the dis, I guess. Return dis dot vj equals vj. Display, we'll create a vj. 0. And now let's create the visuals. So let's say bg background equals, and now we get to use our create empty function, and we can give it right. So s input display bg. Also, when I create empty, I want to set these variables to be like this. So now, if I don't pass in these values, it'll just default to zeros. Stick z create empty. And that'll be s display underscore stick. That x y. Let's see. Let's do a pressed. I guess. So let's do a underscore pressed. Z create empty. Z put a x y. Should be s's. In your destroy event. So your destroy event will happen whenever this object is destroyed. Make sure you destroy all of the things that you create. Okay. Instance destroy. Destroy the background. 1, 2, 3, 4. And so all of the things that you create down here by creating a new object like this, you have to destroy them, because they will not be destroyed when this object is destroyed unless you do it here. Now we just need to update the sprite index every frame according to our virtual joystick. So we'll say bg dot image index equals 1, just always the background is on. Stick image index equals vj.dir. Let's see, stick dot image index. There we go. So frame 0 is blank. Frame 1 is perfectly corresponding with the joystick being in the bottom left. 2 is down. 3 is down right. So all of these work perfectly just like this. So by setting the image index equal to the current direction being held by our virtual joystick, the stick will be put into the correct position. So I could do, for each button, I could do if a pressed dot image index equals 1, else a pressed dot image index equals 0. I could do that. There is a better way to do this using the ternary operator, which is the question mark. So we need a pressed dot image index to equal one of two things based on this variable. And the way you write that is like this. This is the thing that we're saying is true or false. And this value will be changed to 1 if that is true, if vj.a is true, or it will be changed to 0 if it's false. So let's do the same thing for the rest of the buttons. Now we just have to make it happen. Let's go here. P1 display equals the create input display. And then we'll pass it in P1 VJ. And then we'll put it at like 5, 5, 5. I don't know, just to show that it's working. Hopefully, if I didn't forget anything, this will work and we'll be done. That's a problem, but you can see the stick is moving correctly, and oh boy, buttons won't show up because the background is in front of everything. So let's change that. Let's make sure our background is deeper. There we go. Okay, yeah. My buttons are indeed wrong, but they are working. So the stick moves accordingly, and the buttons light up whenever I press them, although they're not the right buttons. And that is everything that I wanted to cover in this video. That was a lot for very little payoff. This video and the next video in particular are going to be like sort of busy work where I'm doing a lot of things behind the scenes that I need to do, otherwise we'll have problems later on. There will be very little to see in the game, which is just something that happens. Thanks for watching.